Good morning, ladies and gentlemen. What we're going to look at today is the terminology and some theorems surrounding circles. Now, what you're looking at currently is a whole series of terminology of things you just really need to know about circles. For example, this left-hand one here, I'm sure you'll have seen before. Radius, center, diameter. A cut that doesn't go through the diameter is called a chord. Now, from here, it may get hopefully still logical, but you may not have seen these before. If we cut a circle into two pie pieces, the small one is called a minor sector, the large one, major sector. This is the minor arc and the major arc. Similarly, but different word, if you cut a chord across a circle, it divides it into two, which we call a minor segment, major segment. Note the confusion that often occurs arising between sector and segment. The way I remember it is sector has a C in it, and the C looks something like a wedge shape coming out of it there, whereas segment doesn't have anything like that. Not sure if that helps you, but find a way that helps you remember it. Alright, then going down here, the terminology that often comes up in worded questions is an angle is subtended by an arc or a chord. This here is subtended by that arc. Then angle here is subtended by the chord. So subtended just means it forms the bridge between the two arms. So angle AOC from the center is subtended by the minor arc AB, and so on. Alright, now those you're expected to basically know by heart. What follows you don't need to memorize. You can either use it, write them on your reference sheet in time for the test, or just need to know the vague logic of it. And the first four chord theorems are basically common sense, I think. What this is saying is that this angle, if you know the angle, and you know this angle, and you know they're the same, therefore you can say this chord is equal in length to that chord. Or another way of saying it is, if you know the chords, if you know chord AB and DC are the same length, therefore you know the angles at the center are the same. So basically, if you know one of those things, the other is also true. Here, if you draw a chord and a chord, and if AB equals CD, so if the chords are equal length, then the distance from the middle of the circle to the middle of the chord, middle of the circle, middle of the chord, will be equal for each case. Again, rather an obscure one that barely ever comes up, but easy enough to know. Same here, common sense. If you have a chord that you cut in half, like that, equal, equal, right angle there, and those angles are equal. Theorem 4 is basically this in reverse. If you know that a line bisects a chord at right angles, it will pass through the center. This here, a line bisects the chord at right angles, it'll pass through the center. It's a bit like saying if you bisect that chord, you know that this little line here, OM, must go through the center. Alright, now the ones that follow are less obvious. You're not expected to memorize them all. You can give them reference sheets. Feel free to print them out and stick them in, but we'll go through where they come from in class. So here, you have an angle at a center and a circumference. So if you've got this, and you know one, you also know the other. So for example, if you knew that was 70, this would be 140. In a semicircle, so if a line AB is a diameter, any point on the circumference, C, will create a right angle. So for example, if I drew C here, that, and this, whoa, that was meant to head to B, will create a right angle here. You're going to have to use your imagination for that one. In fact, you don't have to, because in class, we'll go through this in more detail. Then, here, again, less obvious. But if you have this butterfly setup, where essentially there's a common arc here. There's this arc that D goes off, and the angle at C goes off it. They both face the same arc. Hey, no, sorry, got distracted there. The last circle theorem is dealing with a type of quadrilateral called a cyclic quadrilateral. Cyclic means if you lay out the four corners of the quadrilateral, they all fall on the circumference of a circle. The cool part about cyclic quadrilaterals is the sum of the opposite sides is equal. So AC will add to 180, which means by definition the other pair must also add to 180. Any quadrilateral that has opposite sides adding to 180 is cyclic. Alright, here's one that you are basically expected to memorize, because it comes up again and again in year 11 and 12. If you have a circle and you draw a radius line out and a tangent means it goes along and touches the circle at one point only. So note touching exactly once. It doesn't, not like the line goes through the circle for a little bit, it doesn't miss the circle, it just touches it once. And then that meeting point creates a right angle. So note here, P to A is a tangent. Therefore it meets at a right angle, they're equal. Now, I'd almost ignore that one. Not very necessary. These are interesting, but are not hugely rare. Chord theorems. Sorry, not hugely common. Basically, if you draw a pair of chords that cut across each other, they form a ratio. So if you do A times C, so medium times medium size equals D times B. And you can sort of visualize how this might work out. Medium times medium is equal to small times large. You could vaguely see how that works. And we'll look at it more in class. Then here, two other rules. Both of these are fairly rare, but they appear in the textbook, so we might come up against the odd question against them. Alright, and that is all for now. I realize I haven't done any practice questions. It's mainly a case of taking down some notes and therefore filling your reference books nicely. Thank you very much.